Alright class, now let's step into the code on some of the inheritance stuff that we've been working with and talking about through the past PowerPoint presentation. Now you may not believe me, but we've already done a little bit of work with inheritance already when we start talking about forms. So if you look at the top of this class here, you can see that we have product maintenance is the name of our form, so we have public partial class here. So just like anything else, we're working with classes and we're making our own class. It just so happens when we start a new Windows form project, it usually makes our first class for us, or our first form. But if you notice after this colon, you notice that it inherits, or you can tell by this green color, that it inherits from another class, and if you hover over it, called form, which is in the system Windows Forms namespace of the .NET framework, or of this particular framework at least. So if you go and you F12 on this class, there it goes, you can see that this form has a default constructor, and there is no decompiler here that I have installed, so you really don't see what any of this stuff does. But you can see a lot of the functionality that you have built into these forms by default without actually having to do anything. So you have different properties that we've already worked with called tab index, for example, being able to set what tab it is. Events, you see that we have event handlers here, so you have a closed event handler, so maybe something to do, so you want to notify something when the form is closing. You have a public void close method. So if you notice, whenever we have a button on our form, for example, I don't have a close button on this one, so let's go ahead and put a close button just to show you that you've been working with inheritance already without knowing it. I want to go ahead and call this button exit. Go ahead and set it as my cancel button on the form. Where's my cancel button? There it is. Going to set it to btn. Actually, let's name it before I set it. btn exit. So then when I go back to the forms context and go back down to the cancel button, it has the correct name. I don't know if I rename it after the fact, if it'll take place here too or not. To be safe, I just name it before I set it. And then when you go here and you start typing in close, you notice that you have a close method that you're able to call. And if you look on this form, the close method is nowhere to be seen. I don't have a close method. I have my print to console, which is attached to my delegate for my changed handler of my product list event. I have my load event, and I just have my default constructor that initializes all the components on my form. But I don't have a close method. And if you go back to the form, you notice that we actually inherit that close method from the form class. Form closed. I was just on it. Where to go? Am I missing it? Event handler closed. There it is, void close. So closes the form. So that's why we didn't have to specifically call out where a method was, or make a new object or anything like that to call this close method, because we're already inheriting the close method because we're inheriting from form. So we have an is-a relationship with this form. So remember, we always say we have an is-a relationship that signifies inheritance. Inheritance is a relationship. So what do I mean by is-a? I mean a product maintenance form is a form. So because my product maintenance form is a form, I can inherit everything that form already has tied to it, as well as its events, methods, and properties, and everything else that it exposes to me to use. So that being said, let's go back to our product class. And we have public string get display text. So let's go back, actually before that, let's go back here. And we have a product, which is our product back here. So let's go to product, and instead of remove product, list of product. All right, I have a single product here, so just to show you something, I'm going to do a dot operator. And then you see all of these methods I can call equals get display text, which is shown here. Where is the get display text at? Oh, I'm in my product list, so you can't see it. If you go back to product, we have the get display text method here in a product. So here's my product class. So everything that I make that is an instance of product, I should be able to call the get display text, which should just return all of the text or all of the properties formatted as text. So, but you notice all these other methods I can call: equals, get hash code, get type, toString. So if you go back to product, let's make this a little bigger here so I can put all the code on a single page. If I go back to product, none of these methods are here. You don't see toString, you don't see get hash code, you don't see equals. And then if you look at the top, okay, so it must be inheriting from something. What's it inheriting from? If you look at the top, it's not inheriting from anything. So where are these methods coming from? Why am I able to call these methods on an instance of an object even though I don't have them in my class? And if you look here, it inherits it from object.toString. So remember, in the PowerPoint presentation, everything inherits from the big O object. If you don't specify where it's inheriting from, it'll inherit from object. So, for example, my product list class, I can say product list.toString even though the product list does not explicitly inherit from object. I can still call toString on it because everything inherits from object, and object has toString. So that's why you can call methods that might not necessarily be in your class because you might be inheriting from it. And then even if your class isn't inheriting from object, you might be inheriting from another class that is inheriting from object, such as the form class. So if you go back to the product maintenance form, that inherits from form. So this doesn't inherit from object, but form inherits from object, or form doesn't inherit from object, maybe form inherits from something else even higher. So you can see that container control, that form inherits from container control, and then container control inherits from scrollable control. So you can see this just keeps going up and up and up and up and up and up until finally you get to something that doesn't inherit from anything, that just inherits from object. So you can see how this thing can get pretty lengthy. So now we have an abstract class, Marshall by ref object, which you can see that's abstract, so it's really not used for much but inheriting from. And this thing will then inherit from object. So at the end of the inheritance chain for every single custom object or complex object that is created, you get to eventually the big O object, that you get all of the base functionality that any object has, such as toString, equals, get hash code, etc., etc. So why is that important? A lot of students, what they like to do is, let's say I have a product list, for example. I have a product list, and what they want to do usually, let's make this larger again, and what they want to do is they want to be able to show this list as a string, which is all fine and dandy. They want to be able to show this list, and they want to be able to do this list.toString. So let's go to the product maintenance application. Let's go to the product maintenance load event, and instead of calling this delegate, I'll comment that out. That prints it to console. And instead, do I still have my list products on here? Okay. I want to say my list products .items .add. So I want to put something on my product list, and I want to say that I want it to be products toString. So I have a toString method on here. Why am I not using it? Why do I always for each through every single one of my products to add it to this list? Why don't I just call the list.toString? Well, let's see what happens if I call the list.toString. That prints to my product list text window here. So you see here that I have this product maintenance start.product list. It doesn't really mean anything, it's just garbage. And that's because when I call product list.toString, it's using the object toString. It's not using the product list toString. And that's because I never gave my product list a toString method that overrode objects. So it's saying, I don't know what toString you want me to call, so I'm just going to call the toString that's in your base class or my object class. So let's go back to my product list, and then let's say I don't want to use the object toString method. I want to use my own toString method. So what I can do is I can say public override, and when I do that and I hit space, it's going to give the IDE is going to assume that I want to override one of the methods in my base class. So I hit the space bar, and then it gives me the methods that are available for me to override. So I want to override the toString method. So now I have public override of toString, and just to give me a base implementation, it says I'm just going to return the base.toString, which we don't want to do. I want to return my own implementation of toString. So instead, I'm going to return, I'm going to say var string var s equals string.empty. I'll go ahead and format this list as a string, and I'll say return s. So that way my error goes away, and then I'll start for eaching through this. I'll say for each, and I'll reference my product list. So for each item in products, or I can say for each product in product, s plus equals product dot, I think it's called get display text. That might be a method call, and I might need a separator, so I'll pass a comma. And then let's just leave it like that, actually. So I have a string. For each product in my products, I'm going to call get display text and add it to my empty string, and then return that empty string. So now I overrode the toString method, so now I'm going to come back to my product maintenance application. So now once I call listItems.add products.toString, it should no longer say object.toString, it should say productlist.toString, and it does. Productlist.toString. So now it's a different implementation of the toString method. And you'll notice it's just a concatenation of all of my objects here. This might need to be bigger to see them all, but you notice that now the toString implementation is different. So that's how we can reuse methods, reuse a lot of properties and code without having to reinvent the wheel every time we want to make a form. We can just simply inherit from form and then start building one that's custom to what we want to use. Okay, that being said, let's go ahead and make some different products here off of this product. So the first product I want to make is a book. So let's go ahead and add class, and I'm going to add class book.cs. The class is still highlighted. I'll click add. I'll go ahead and make this class public. Okay. And now a book is going to inherit from product, because a book is a product. It is a product that I'll be selling on my Amazon website or whatever website that I want to be building here. And I want a book. So what's different from a product is I want my book to have an author. So public string author. I want the ability to get and set that property. And now I'll go ahead and give my book a default constructor that I probably won't use. And then I'll give my book a constructor that takes all of the parameters. So first of all, I want to take all the parameters that a product has. For example, a product code, the description, and the price, which I believe is a decimal, and the author. And once I've done that, I can say that the author equals author that got passed in, and everything else can go to my base implementation. So I can call base here, and then I can pass it code. You can see that it knows I have a constructor that I'm going to go ahead and pass everything to. That's already in my base implementation, decimal price. So whenever somebody comes and makes a new book and they pass it all 4 of the parameters, I want to say, okay, go ahead and pass the 3 parameters to my base class and set my other parameter here on my subclass. Also, much like we did with the toString method, I'm going to go ahead and override the getDisplayText method. And you see here that I cannot. And there's a reason for that. The reason I cannot is because I need to come back to my product class and mark this as virtual. What that means is classes that inherit from me can override this method. So now when I come back to this book class and I say public override space, now this getDisplayText comes up. And then much like for my previous one, it returns the base, so I'm going to say no, I don't want to return the base implementation. I want to return my own implementation for book. So I'm going to go ahead and use a lambda expression. So I'm going to say this dot code. I'll just go ahead and format it like I did the other one actually. So I'll say code description plus a separator plus a space plus a price dot toString formatted as currency plus a separator plus a space plus an author. Am I missing that? Okay. So whenever it calls getDisplayText for book, I want to return code plus whatever the separator is, plus description plus whatever the separator is, plus price, whatever the separator is, plus author. So now if I come back to the product maintenance application, let's first come to my product list. When am I adding things to this product list? Am I doing it in the service? Yes. So I'm adding a list product, and let's go ahead and add a new product here. But I'm not going to add a list product, so let's add a new book. Because a book is a product, and notice here, IntelliSense gives me all of the things that I can use here. And I want to use an author. Let's say J.R.R. Tolkien. The code. The description. Fellowship of the Ring. And the price equals $20. Okay, so notice that I'm putting this book into my list of products, and I can do that because a book is a product. It has an ISO relationship because it inherits from product. So let's go back here and see what I believe I have a toString implementation of product. When I go back to my product maintenance application, let's go ahead, let's keep this delegate commented out still maybe. Yeah. I'm going to go through and add these items to the list again, but instead of calling my toList implementation of toString, I want to go and for each through my product list. So I'm going to say products.forEach. I might not be able to do that because I don't use the IEnumerable interface, so I might need to do the products.database.forEach. So I'm going to say for each product that I got retrieved back from my database, .items.add get display text. Nope, didn't mean to do that. Okay. And it needs a separator, I would assume. Okay. So products from database.forEach, I want you to go through each item in the database that I get back that I'm calling X. I want you to add to my list of products.items.add, and I want you to add that product's display text. So let's see what that gets back. When I go to book, I overrode get display text, but it might not use this implementation because right now everything is a book. I might need to cast it to a book for it to know that it's a book, because right now it just thinks it's a product because it's a list of products. So let's see what we get back. That's X here. I think I forgot to comment out this. Yeah, I don't want this anymore. Alright, let's try that again. Okay, so now we have this, and we have the code, description, and price plus the author, so I was wrong. So the code was smart enough to know that this get display text for a book is different than the get display text for product. And it actually used this get display text for product without us having to change any code because I inherited from that class and overrode that implementation in my book class. So you can see how easy it is to be able to reuse everything we've written already, to be able to override methods and be able to display things in the code not caring what type it is, just knowing that it has an ISO relationship so you can use it in lists with each other. So you can even add more types here. Instead of a book, you can add software, even that has a version, and from there you can add a software to this list of products and be able to display those without any problems being added to this list. Just simply getting them back from a database and popping them out on a screen using polymorphism. So I hope this helps with inheritance, and I'll see you in the next video. Thanks.